Good morning, everyone. Welcome to this workshop organized by the project Omega-X. And during next 2 hours, we will discuss and talk about the standardization activities and learning and recommendations on activities developed not only under Omega-X, but also under other energy projects. And here you can see the agenda for today. The first part, we have representative from different standardization bodies and also experts on standardization, as Antonio Kuhn, that is also leading shared standardization task. And then on the second part, we have the point of view of projects, Omega-X, Fatma explaining the common semantic data model that is a good result from Omega-X. Also in this part, we will have Javier Valino and then Eri Makeda explaining the activities developed between all the energy data spaces in order to achieve the interoperability. And then we have a part for discussion. Let's start with Arturo Medela, but unfortunately, he cannot stay with us because personal problem, but he has recorded the welcome. So 1 second, I will try to put the video. Here it is.
I wish I could be there with you today, but unfortunately, and due to unexpected circumstances the moment we fixed this workshop's date, I can't. However, please allow me to provide the introduction to this session through this video. I hope it helps set the stage for what's to come. I am delighted to welcome you to today's workshop, organized by the Omega-X project and its leader on the standardization, Silvia Castelví, focusing on the critical role of data spaces in the energy sector. This is a 2-hour session aimed at fostering collaboration and strengthening connections with some of the key standardization committees that are shaping the future of data spaces and smart grids. We are here today not just to discuss technical details, but to explore how we can align efforts, share expertise, and contribute to the wider ecosystem of energy data spaces. The energy sector is undergoing a profound transformation, and as we shift toward more digital and interconnected systems, interoperability becomes a cornerstone for success. It is no longer enough to have isolated systems operating in silos. What we need is seamless integration, where data can flow freely and securely across boundaries, enabling smarter, more efficient, and sustainable energy systems. This workshop is all about tackling the technical, organizational, and regulatory challenges of making that vision a reality. Over the next couple of hours, we will engage in discussions on several vital topics. We will start by reviewing the current state of standardization activities in the field of data spaces and smart grids, exploring the progress made and the key areas still requiring attention. We will hear from experts about the most pressing priorities for standardization bodies and look at how we can contribute to shaping these standards in a meaningful way. The session will draw on insights from the Omega-X project as well as other related initiatives, which have been working tirelessly to advance the implementation of data spaces within the energy sector. One of the highlights of our discussion today will be the findings from the Omega-X involvement on interoperability frameworks in the energy data spaces domain. This action has been focused on identifying both the gaps and the best practices in the sector, and we are eager to share these insights with you. Understanding these gaps is crucial because it gives us the opportunity to develop actionable recommendations that can help guide standardization efforts going forward. It is these recommendations that we hope will be both practical and impactful for the standardization bodies, offering concrete steps toward improving energy data interoperability. A key theme throughout today's session will be the challenge of interoperability, both vertical and horizontal. As you might already know, vertical interoperability refers to the smooth integration of systems within a single domain, while on the other hand, horizontal interoperability looks at how different sectors or systems can work together. Both dimensions are essential to creating a fully integrated and functional energy ecosystem, and we'll have a chance to explore these issues in more detail during our discussions. As you know, our work here is not just theoretical. We have analyzed the needs, identified the gaps, and gathered the key findings from across the projects and communities involved. From this, we aim to develop concrete, actionable recommendations that we can present to the standardization bodies to help guide future standardization efforts in energy data spaces. This work has been years in the making, and today we are one step closer to ensuring that energy data is connected, secure, and usable as it needs to be. We are fortunate to have a highly experienced panel of experts joining us today. Representatives from the Omega-X project will provide an in-depth look at how we are approaching standardization, with a particular focus on our common semantic data model for energy and the interoperability framework that we are developing. We'll also hear from our esteemed colleagues from CENELEC, JTC, the IoT, and the Eclipse Foundation, particularly from the Eclipse Dataspace Working Group. Each of these organizations brings valuable perspectives grounded in real-world experience, and we look forward to learning from their insights as well. Today is all about collaboration and dialogue. The challenges we face in creating interoperable data spaces for the energy sector are complex, but they are not insurmountable. Together, we can develop solutions that drive forward innovation, improve energy systems, and create a more sustainable future. I encourage you all to be active participants in today's discussions. Whether you are sharing your own experiences, raising questions, or offering suggestions, your input is invaluable. This workshop is a platform for us all to engage, learn, and contribute toward the shared goal of creating a better energy system for everyone. Without further ado, let's dive into the discussions. I'll now hand over to our first speaker, Sebastian Steinbuss, who will provide an overview on the CENELEC vision. Thank you again for being here, and I look forward to an engaging and productive session ahead.
Okay, Sebastian.
Yes, thanks a lot. Thanks a lot. Thanks a lot for the nice words for the introduction. I could not agree more to what was said and how the things fit together. Let me share my screen. I hope it's nicely visible. So today I would like to present you how projects like Omega-X, for example, can support ongoing standardization activities, for example, in the CENELEC JTC 25 and beyond. So how such activities can be nicely related to the European data strategy and especially the standardization requests subsequently to that. My name is Sebastian Steinbuss. I'm CTO of International Data Spaces Association and also the chair of JTC 25. I would like to guide you a little bit through the work of JTC 25 and the related standardization request. So let's start with the standardization request. The standardization request on the European Trusted Data Framework, which is nicely derived from the Data Act especially, but also connected to other European regulations like the Data Governance Act and others. So it sees a couple of aspects that need to be standardized. So the standardization request asks the European standardization bodies to come up with standards that help to support the implementation of European regulations. So in this standardization request, we have 5 standards that are requested to be delivered. Honestly speaking, it's not 5, it will be 7, and I will explain you in a bit why it's 7 and not 5. So we see in a data space that on the one hand side, you see it on the left, data space requires good governance, it requires supporting services, and it requires protocols, so interoperability mechanisms on the real technical level that support us. And in data spaces, we talk about the interaction between the data holders on the one hand side and the data users or data consumers on the other hand side. And here we have a very nice example of this horizontal interoperability. Here we need standardized mechanisms across the different domains and sectors for data discovery, negotiation of data sharing contracts, and then the management of the actual data sharing that will happen. While the data sharing, there we really need interoperability in the sectors, because we talk here about domain-specific data models, for example, or domain-specific data exchange protocols. So, and of course, sometimes we need the support of intermediation services, however they look like. They could be very, very different. And this is where the standardization request asks for standards, for the trusted data transaction standard that I will explain a little bit more in the detail, a data catalog implementation framework, a data governance standard for data space participants, semantic asset implementation framework, and a maturity model for the common European data spaces. So this is the brief intro. This is why JTC 25 and also the ETC data are established to really work on those matters, on the standardization request, but also on standards and specifications, technical specifications that go beyond that. So JTC 25, very short the scope, which is quite generic, covering data governance, data quality and data lifecycle management, interoperability, portability, switching of cloud providers, organizational frameworks, methodologies, processes, products, evaluation schemes, smart technology, objects, distributed computing, devices, data services. So in general, very broad, but really specific for data spaces and also the cloud and edge field. JTC 25 was kicked off in September last year, September 2024. We had our second plenary meeting in Milan just in February 2025, and we will meet again for our third plenary meeting in May of this year. So this is a little bit the boring part on how such a standardization body is structured. And this includes that we have working groups. We have 4 working groups in JTC 25. We have an advisory group. The advisory group continues the work of the CENELEC focus group, data spaces, cloud and edge, is coordinating between the different working groups, supporting and also coordinating with our liaison partners so that we can nicely connect to all the other projects that are doing great stuff, organizations that are doing great stuff, and other bodies in standardization that are doing great stuff to keep everything aligned and come up with consistent standards. This group is chaired by Andrea Katscher. We have our working group 2 with Patrick Besoms and Martin Brynskov. I think Martin will speak a little bit later today as well and give you details on that, working on data spaces. Our working group 3 on data management and data governance, chaired by our dear colleague Ismael Caballero, and our working group 4 on cloud and edge, chaired by Michael Bolhus. And we have the best community manager and secretariat in the world from Italy, which is Helen Carnevale here in our JTC 25. So what is our work plan? I briefly mentioned the items from the standardization request, and you see here on this slide, those are the 7 deliverables that are requested now. And you see that the trusted data transaction as one core standard and to be a harmonized standard is sliced into 3 parts, into a part 1 on terminology, concepts and mechanisms, part 2 trustworthiness, and then interoperability requirements. I will come back to this in a little bit later. We have the request for a technical specification on data catalog implementation framework. Here we expect that this item will be taken over by the ETC data that I will comment on in just a bit. And likewise, a technical specification on implementation framework for semantic assets. We are doing some preliminary work, but we also expect that the TC data from ETSI will take this over. And then we're working on the European standard for a quality framework for internal data governance and the technical specifications on a maturity model for common European data spaces. You see in the middle column the deadlines. So the first documents shall be delivered early 2026, in a year from here. And for a standard process, this is really, really not much time. So we really need to deliver those things. And of course, we have to, because the Data Act comes into force in this year, and we need to provide good standards that supports implementation of the Data Act and other European regulations. Briefly on the ETSI data, the ETSI data will take over and continue the work of the ETSI committee Smart M2M. It will be kicked off mid of April, so I think in 2 weeks from here, April 14 to 17. And the TC data shall also develop technical standards to support data interoperability and semantic interoperability. I will not go into details of the ETSI data, but you can see the nice press release here, and also the terms of reference of the ETSI data are published. I will also put the links that I have here on the slide in the chat later on so that you will have it immediately and not only when the slides are shared. So what are the things that we have to do? And I would like to bring a couple of concepts that we are working on to your notice because I think they're really important, also following up on the great introduction we speak. So this is one of the key graphics from the trusted data transaction. The trusted data transaction was started in a CWA, in a CENELEC workshop agreement, because there was no technical committee or joint technical committee that could develop such a standard. So a pre-standardization work coming up with the key concepts and terminologies and mechanisms for trusted data transactions. And here are two very relevant parts inside. One aspect, the interoperability part, so how a data provider and a data user interact with each other, publication and discovery, so talking about catalog information, about DCAT and DCAT's application profiles, negotiation of data usage or data sharing contracts, and then the transaction, the actual exchange or sharing of the data, and then the access and usage. Of course, always connected to those data sharing contracts or licenses that are attached to the data. And the other aspect is a so-called data product. So the second part where the CEN workshop agreement trusted data transaction is currently still working on are the trustworthiness requirements. So what makes such a transaction really trustworthy? And here we talk about trust as a decision. I do decide as a human being, as an organization, as a system to trust another system, organization or human or not to trust. But I need a foundation for this. This is where we talk about trustworthiness. What are the trustworthiness aspects? And here we just talk about, well, this is my bag of evidence. Technically, my claims that I can provide, I am certified, I'm a human being, I have an identity, whatever. And how can we exchange and validate such trustworthiness aspects? This is subject to the second part of the trusted data transaction that is at the moment ongoing under the CWA, but all the three parts are picked up at the moment in JTC 25 to become really harmonized European norms. And then the third part on interoperability, how the interoperability will interact. This is a project that just starts in our working group 2. So I hope that I don't steal too much thunder of Martin on that one. But what we are working on as a foundation is, of course, interoperability standards, like the data space protocol, for example, that describes as a technical specification how this horizontal interoperability can be implemented and how it connects to the domain-specific parts in the data planes. I would like to bring one more concept to your notice that I think is really, really super important when we want to discuss how the work of energy data spaces and Omega-X can be also reused in the standardization activities. When we talk about those data products, in the trusted data transaction, what we understand here as a data product is a combination of data, metadata, and services. I know metadata could also, again, be data, that could also be a data product and so on, but I will not go into that direction. What I would like to put a spotlight on here is metadata is in general data about data, and this could be basically everything. So it nicely connects to a lot of different data quality aspects that we need to consider in the standardization work. But the focus is on cataloging information, so how to publish and discover such data products in a data space or beyond, that I can describe the semantics, the understanding of the data, so the whole semantic assets, and here not describing the semantic assets in detail, but describe the criteria, how to describe good semantic assets that make data understandable. And of course, the aspect with this very European term data rights. So what are the policies, the data sharing contracts attached to this, and how to implement this also, for example, based on ODRL. These are the three key pillars when we talk about metadata. And of course, knowing there could be a lot more, but when we take a look at the standardization request, this is a focus. And then, of course, subsequently to the technical question, how can I erect a good governance and a good management of the data and the metadata on both ends. For me as a participant in the data space, especially with a focus on small and mid-sized organization, but in the end applicable to organizations of all size and types, but also how to set up a good data governance and management on the foundation of a data space. What are the governance rules inside a data space that all should adhere to? This is one of the key, these are the key topics in JTC 25 for the next couple of years at least. So, what shall we do now? What is super important? There are a lot of more standardization activities with data spaces, horizontal and vertical. So we need to know that those are happening and we keep those activities aligned, as said, the horizontal and the vertical ones. We have some time pressure with the Data Act, so we need to move now fast and do something and deliver good things. And what is for me a very personal thing also is we need to keep the standards aligned with the implementing projects. We should not end up in great standards that are there and great implementations on the other hand side, and they are not connected with each other. So we need to assure that the implementing project and the standardization work is aligned. And therefore, my last call is here. Join us in the standardization of data spaces. We are doing this work now. It's open to everyone to join via your national body. Join your national body as organization and be part of the standardization work, or like a project like Omega-X. Well, maybe it's too late for Omega-X, but all the other great projects that you're doing, liaise with our JTC 25 or the HCTC data and support the standardization work. And with that, I would like to say thank you, and I think I hand back to you, Sylvia.
Yes, thank you, Sebastian, for introducing us on the current status of the standardization that impact to the data spaces. And we are happy to contribute, providing, identifying challenges and providing recommendation. Next speaker will go, it's Martin Brynskov, and as chair of the GTC 25 Working Group 2, he will introduce us on the, you have a huge work or mandate to standardize in this working group. So Martin, you have a lot of work next year. So welcome here, and the stage is yours.
Thank you so much, and thanks for reminding us of the scope of the work. I hope you see the slides and you can hear me.
Perfect.
Fantastic. And thanks also for the nice introduction, Arturo. Sorry about the situation, but very nice to see you give this context. Also linking back, I think, a decade to see how those discoveries that were found in these collaborative efforts in Europe in the research and innovation environment, how they very early on identified these very tricky T-shaped challenges with data being shared in the sector and between sectors. And as the world has shown, this was very timely. Thanks also for the invitation. And Sebastian, it is almost as if we had planned this, because I will focus on part 3, where you so nicely set the context, of course, for the JTC 25 work in general, but also the first 2 parts. It's my pleasure, together with Patrick Besson from France, to co-convene the Working Group 2, which focuses, I think the heading is actually data spaces within the trusted data transactions. And that's a portfolio of activities in there. So let's have a little bit of a look on that, and I will focus on the interoperability part. This is a short subset of what was already shown from Sebastian. So we have these 3 parts: trusted data transactions part 1, which is a very short one, 10 pages, something like this, with the terminology, concepts, and mechanisms. But man, I mean, try to come up with the concise, sectorially cross-cutting terminology, concepts, and mechanisms based on, well, we can almost say millennia of concepts and mechanisms around information sharing. So of course, there's a lot of alignment going on between what's already existing in Europe, in the world, and in the sectors. We have a fairly tight deadline because we have almost promised to deliver this by June next year. So the standardization request coming from the European Commission is being processed, but we really assume that this will be the plan. Then, as Sebastian showed, there's also part 2, which is on trustworthiness requirements. And while the first part doesn't include requirements that you can implement if you have a technical offering or operation set up, part 2 certainly does. So that's going to be like 100 pages with requirements. But again, instead of hiring 5 lawyers, you can just be compliant with the standards, and then you're fine. At least the regulatory authorities will come after you last. This has a little bit of a longer delivery time, but still very, very fast. Normally, we would say 3 years to develop a European harmonized standards. In rough measures, 3 to 5 years, depending on how complex. So this is extremely fast, and I'll comment on this in a moment. This is also based on a CEN workshop agreement, meaning there's actually 2 focused years of solid work that has already been put in this with many of the colleagues involved. And I see even here in the audience today, several of the colleagues also from that work present. Then there is part 3, which is a little bit more tricky. Not that there hasn't been work done on interoperability. I mean, if you look at Omega-X and what's been done in the context of that particular action, interoperability has long been identified as an issue. But then coming up with a consensus for the sector, as well as for the related sectors, you could say the cross-cutting parts, the common parts. That's extremely difficult. And of course, it's impossible to do for one action, or I was going to say even for one continent, or perhaps certainly for one country. But at least I think we have a very good understanding of what the challenge is. What we also do have is that we have a very good working environment with both the European and the global vision present. So I'm very confident that by May 27 or therearound, we will have a norm which can actually help everyone who wants to leverage the data-driven delivery of energy services in Europe. Then there's part 7, which we also have in Working Group 2, and that is the maturity of data spaces. That derives its basis very specifically from the common European data spaces that are collected in the Data Spaces Support Center. And that is emerging work, but again, it stands on a very solid pillar of work. That's going to be delivered a little bit faster, but it will be less normative. So one thing to keep in mind, and I think this is a realization that all have had, but maybe has not been so explicit. So in Europe, over the last 10 years, there's been a shift from creating directives, legal acts that then needs to be implemented in the member states in different ways. And that creates a little bit of difference from territory to territory and from country to country. So there's a shift towards acts, which when they are decided by the European bodies, then they are immediately law in all of the European Union. So that's a change. We saw that with the GDPR, we've seen it with the AI Act, and now with the Data Act, the Data Governance Act, Interoperable Europe Act, and so on. So that is a common or a general shift that's happened over the last 10 years and very strongly over the last 5 years. And now we see these coming into force. But the way to actually implement this is to have standards that make you, assumed compliant if you follow the standards. And that puts a lot of pressure on the standardization system, but it also gives a real opportunity to make the legislative part operational. So this is an invitation to come and help everyone, and I would say in Europe and beyond, to be very practical about the values and the ideals we would like to see being the basis for our infrastructure and service delivery. Now, just 2 words on the actual part 3 on interoperability. There is a proposal now. I'm not going to go into details. This is more just to show the nature of the discussions of the work. So it's about the essential requirements for participants in data spaces, of course, who can participate and what can be shared and so on. There is a scope which is being proposed from the standardization request that we have received. And then we have from the German colleagues already a proposal on how to translate this into a good framework for a norm. So this is just to show the practical, everyday, I was going to say, work of the standardization working group. We have weekly meetings, which is fairly often for this type of community. But this is also an invitation to join. And yeah, I see several of the colleagues also. Thanks for all your commitment to this. It's, of course, things that we know extremely well that should be hammered out. Observability, auditability. There's, of course, a lot of security issues that need to be handled. And, where does that happen? There's a lot of standardization around that. There's an overall timeline. I don't want to bore you with that. We have, in this case, we alternate between parts 1 and 2 every week or 1 week. And then the other week we have part 3 and the maturity of data spaces. So there's a lot of rolling work. And if you want to take part, it's really, to read documents, discuss documents, and provide input, and then it rolls. And it's very, very fast in quite concise windows of contribution. One of the things that we're discussing is, of course, how we leverage what is already existing in the standardization world. And one way, those who know me, of course, knows that we have, from many sides, been trying to see what is the minimal interoperability we can establish, and how can we implement not only mechanisms that establish these interoperability requirements in different ways, but also how can we ensure that they all conform and comply through rigorous testing. Seeing Arturo, I think you were responsible for this in the synchronicity action back in the day. So, in that sense, nothing much has changed, but it's really becoming real. So the main challenges that I see for the energy domain is the plethora, actually, of legacy standards. And Antonio will, I'm sure, be much more precise in how to link these different ones. But overall, you could say there is a fragmentation between IT, operation technology, OT, and then energy, if you will, be very, very, very overly simplistic about this. And these are also practices of communities of practice and of, you could say, careers. So it's very long trajectories in professional lives that we are trying to merge here. And that's probably one of the very essential issues. Then there's the regulatory market diversity, and we are pressed for time. But I think we will have a quite good opportunity to do something about this. And that was all from my side. And thank you so much for the excellent opportunity to catch up on these things. And I invite you with Patrick and with Sebastian to join your national standards organization and to pitch in here. And we really invite also expert comments from the projects such as Omega-X. Thanks for all the hard work that you've been doing. And thanks to all the colleagues.
Thank you, Martin. Great explanation, and I like a lot that you have explained it, that we need to merge the IT part, OT part, and then the energy-specific standards. And yeah, as you know, Omega-X is implementing data spaces on energy sector, and we want to contribute also to the energy sector. And we have a representative, Olivier Genest, from Trialog, that is member of CENELEC coordination group on the smart grids. Thank you, Olivier, for staying here and introducing us on what this coordination group is doing. Welcome. The floor is yours.
Thank you, Sylvia. I hope you can see my screen and hear me very well.
Yes, perfect.
Okay, great. So today I will be presenting what is done in the working group set of standards of the coordination group at smart grid at European level, we're gathering CENELEC and IDSA. So the scope of this coordination group on smart grid is to do coordination between technical bodies. So we are not ourselves developing standard, but we want to make sure that we are identifying the right gaps and that we do proper coordination for standardization in topics related to smart grid, including smart metering. So this work is done among the technical bodies that we have at both CENELEC and IDSA. And objective is to ensure that we don't have any conflicts or overlaps, in particular when we have horizontal topics, but also to push some recommendation when we identify that there is a gap or that something has to be fixed. So if we look at how this coordination group of smart grid is organized, we have a steering committee which is having coordination with other groups. So there are other coordination group in CENELEC, in particular one on e-mobility, but also making connection with TCs or with external bodies such as the IDSA System Committee Smart Energy or the bridge initiative of the Horizon Europe and Horizon 2020 program, and other groups like on coordination group on hydrogen. We also have some connection with observers are not at European level. We have in particular some good connection with Japan with the GISC. We have a yearly meeting to coordinate activities. And inside the coordination group, we have several ongoing working groups, or sometimes renamed as ad hoc groups. One of them is security and privacy, but it's on hold currently. But the main three active is one on a set of standards. I will further explain, one on the EU policy and one on smart metering. There is currently some work at CENELEC to try to reorganize how are done the coordination groups, and it may happen that a new coordination group called All Electric Society will be created and probably will merge activity from smart grid, but also probably from other topics. So if we look at what we have in this coordination group on smart grid, which is also CGSG, because sometimes the exact name has changed a bit. But so we have this set of standard groups that is trying to maintain the list of European standards that need to be developed, to propose some work program to the ESOs, European Standardization Organization, to share some comments and to monitor developments that are being done. In particular, when we have new topics like, I don't know, flexibility, semantic interoperability, or data space, how we can see what could be the possible gaps and make sure that we have the right coordination, standardization work. Also, we provide some feedback to the European Commission with some recommendations depending on what we can identify. We have the group on EU policy. In particular, we have some coordination to the newly created Smart Energy Expert Group, where we have several activities. One is, of course, the data for energy working group, but we have also other topics, consumer empowerment and protection, and cybersecurity, which is a kind of continuation of what was done in the Smart Grid Task Force, where also CGSG was very active. We are also following legislation related to the clean energy package and other key topics that we have there. And there is a strong coordination with between the EU policy working group and set of standard to make sure that we have the right standard to map to the future regulation. And finally, we have the working group smart metering, which is specifically focused on the smart meter topic to support interoperability, look at what is the rollout of advanced metering infrastructure, also to share some comments related to smart metering standard and monitor development of new activities, and in particular connected to regulations such as the RED regulation and the Cyber Resilience Act. So if we zoom a bit into this working group set of standards, we have several ongoing discussions. One of them is that we have a strong cooperation with the IEC System Committee Smart Energy. So similarly to coordination group, at IEC level, System Committee is not developing standards. Objective is more to ensure cooperation and follow what should be the roadmap and development plan for standards. So there is a connection with the working group 2, which focus on standard gaps identification and follow-up of the standard development plan. There is also a strong link with the Joint Working Group 3. I'm co-convener of this group, and which is in particular maintaining a list of standards which is freely published on the System Committee Smart Energy website. You can have a look to this link, and you will see for each of the domains what are the list of relevant standards that may be under development or already published. Also, we discuss about what standards are required to support the regulation. In particular, we have this network code on cybersecurity, and we have the new network code on demand response and the implementing act related to the electricity directive. We have now for maybe 2 or 3 years a good liaison with Bridge Data Management Working Group. So Bridge is an initiative gathering all the Horizon Europe, Horizon 2020 projects related to smart grid. So it's a good connection with research and innovation because it enables to provide them more information about what is ongoing at standardization activities, but also to get feedback from them about the possible gaps that we have in the current existing standard, or some useful feedback on the implementation of newly developed standard. So for that, we have a Bridge Standard User Group, BSUG, and we are maintaining also a playlist with several webinars that we've been doing, so we can send them to this Bridge project so they can be better educated on what exists at standardization level. We are also covering topic of smart charging in coordination with the e-mobility coordination group. I mentioned earlier that the D4E data for energy working group is ongoing, and in these activities, we are not only looking at flexibility, but also looking at e-mobility. And also we have started a bit more than 1 year ago, a big work to update the generic actor list. So when we are defining some use case based on IEC 62559-2 template, we need to indicate some actors, and there is a need for alignment and consensus on how these actors should be described. And there was some work that was done in 2012 at the time based on the harmonized electricity market role model and on some IEC standard to define a generic actor list. But of course, since 2012, many things have changed, so we are currently updating this list. Because we have this connection with EDSI, it's also a good opportunity to discuss about connection and consistency between IEC standard and EDSI development. We had in particular a workshop in January 2024 involving people from EDSI, from IEC TC57, and several other committees, in which we discussed about the consistency between SAREF and SAREF for NR or SAREF for grid, and what was developed at IEC and used by several system operators and manufacturers related in particular to DNMS COSEM, to SIM and 61850. Following this workshop, we had a discussion to establish what you call a gap form, meaning that we are describing what is the challenge that we are facing related to the way SAREF is developed and how we can ensure a proper consistency with these IEC data models. And we are currently following up on this recommendation, not alone, but in cooperation with several groups involving INET project, but also a joint research center from European Commission. In November 2024, we also had a workshop on demand response and standards. And it was a very good workshop in which we had speakers from several actors, but like Enedis, RT, for French system operators, but we also had someone from the EU DSO entity and ENSOE joint working group. We had a representative from the Smart Energy Expert Group Data for Energy, also from Bridge, also some connection with the GRC Code of Conduct for Energy Smart Appliances Interoperability. We also had people from the new IDSA System Committee Smart Energy Ad hoc Group 11 on flexibility. Some people from IEC who are developing a guide on energy flexibility, and also some technical committees, of course, both from IEC and CENELEC, so they can present what is ongoing and make sure that everybody is aware of what the other committees are doing. Also, there was a workshop between the TC13, SC23K, and TC205, and we are following the work that needs to be done after this workshop. And we are ensuring this liaison with a joint working group between ENSO and EU DSO entity on topic related to data interoperability, in particular what is called the stakeholders panel, meaning that people who are not part of this joint working group can still have some news and provide some feedback on the ongoing development. So to finalize, we are now looking also at this data space topic, in particular how we believe that semantic interoperability can support a smart grid and smart energy system. We are having this work in the IEC System Committee Smart Energy with a system reference deliverable IEC 63417, which is a guidance and plan to establish smart energy ontologies with some concrete recommendation to enable to develop this kind of activities. Also, we are always relying on the core standard data model of the smart grid domain, which are referenced in this IEC 697, which is smart energy roadmap I mentioned earlier. And in particular, we have this data model from IEC TC57 on SIM, and including the 61970 and 61968, which are the main SIM for the network, but also we have 62325, which is more about SIM market, and also we have 62746 that also cover topic related to flexibility with a new Dash4 that was released recently. And of course, in IEC TC57, we also have the 61850. And also we need to make sure we have consistency with the IEC TC13 standard, in particular DLMS COSEM as part of CC2056. And finally, we are having connection with this energy data space cluster project, so we can gather the lesson learned related to semantic interoperability and identify some useful recommendations to make sure that this activity will have a continuation for the future. Thank you. We cannot hear you, Sylvia.
Thank you for great explanation. It has been super interesting for the energy domain. And now I have the pleasure to introduce you Antonio Kuhn. So welcome, Antonio. It's a pleasure to have you here. I don't know which title to put you, because you are an expert on standardization, but also leading energy standardization task, representing IoT standardization working group. So, okay, I give you the floor to you and introduce us on the topic of the standards.
You see my screen, right?
Yes.
Okay,
perfect.
So hello everyone. Title of my presentation, Ecosystem Standards. Yeah, so just say that I'm doing many things, but in particular, I am now responsible for standardization for both AIoTI and BDVA, okay, which creates links with SC41 IoT digital twins, SG20 IoT and SCC, and also SC42. And I want to say that currently I'm editing 8 standards which have a link to what we are going to talk, and in which we can provide contributions. Of course, I will ask you to provide those contributions, okay? So I want to say that we are also involved in undertaking on what's called CEI, Cloud Edge IoT. And of course, at the end of Cloud Edge IoT, you have data space, okay? So you see here, you have a picture, we call it the hourglass, where we have an infrastructure, we have here the data space, here we have the platform, come back to that, and we have two big projects and several others, OCI Copilot, which was started early January, which want to provide, let's say, those technologies, okay? And this vision of the hourglass, we have started it in 15th of January, but we presented a number of times. So actually, here, so in January, in February, in March, and last week, okay? So I just want to say what it is about, okay? So actually, we want to show that it's not only technology, it's also the stakeholders, their business, and the capabilities they provide. And we need to shape the ecosystem such that this can happen, okay? So you see here, you have, for instance, two examples, but in reality, the objective is that for us is to have reuse. So you have those building blocks, which actually can be reused, of course, by several undertaking, pilots or whatever, okay? And what we want to avoid, which is the big challenge, is fragmentation. So it's to have, well, of course this can happen, but in reality, we want to optimize the whole business so that we have opportunities here and here. So this is definitely not what we want to reach, okay? So in order to do this, in technology, the current vision that we are promoting is this hourglass model, where below we have the infrastructure. On top, we have, I could say, to simplify, the data space and what it enables us. And in between, we have the MIM, the minimum interoperability mechanism, which Martin has provided, okay? And this is the vision that is quite clear, and we try to push that because it can enable, let's say, the prosperity of each part with this intersection, which creates the links, okay? So how do we do this? First of all, we need to have reusable architecture elements. I call them architecture patterns. It's under discussions at the standardization level, but we need to provide the flesh, okay? And of course, implementation will do this. So you have in the architecture common foundation, patterns, and of course, you provide the capabilities, of course. And of course, you do this because you have the stakeholders are doing this, okay? So then what does it take to make it happen? Okay, so we have this, let's say, acronym IMO, IM optimized, where we need to agree on information models. We need to agree on building blocks. I'll come back to that because we have patterns and you see the term MIM, okay? Then we have here the profiles, and this is really what is important. In reality, what we have here is a specification of what it is you need to make it happen, the profile, okay? And the profile is, in general, a bunch of building blocks with all their parts, the part of the MIM that is related to it, okay? But this is the vision. We need the availability, we need accessibility, we need building blocks that are implemented. And this is where open source can play a role, okay? So we are using this acronym IMO, IM optimized, okay? So what is at stake also, I want to highlight that, is that in reality, we have a whole bunch of regulations. I didn't mention all of them, but you might recognize of them, okay? And some of them, I colored them. I try my best to focus on actually the harmonized standard that actually associated. Of course, you see, we had a nice presentation on DDCE, JTC25, which is related to a number of regulations. I put GDPR because GDPR, even though it was much before, it is something that is definitely a concern in JTC25, okay? And in the future, if we do it properly, so this is the vision I'm proposing, is to have what you call a minimum conformity mechanisms, MCM, which you can use to make sure that here, with this virtual reusability, we can also reuse all the artifacts we are using for making sure that we are consistent with the harmonized standards, okay? So actually, this is the message. I just want to show to you that it's not easy because I'm going to show to you what is going on in terms of standards, okay? So, and I've just shown this several times, but when it comes to standards, you have here a number of standards on data, okay? But then you have interoperability. You have also a number of other standards in interoperability. Also, you have a color here, green, which means published, but red, which means under construction, under development. So we can also, let's say, influence it. And of course, you need to have the data space, so 2151 SC38, which is underway. By the way, it's going to get to DRS, so we are pretty confident that next year it's going to be published. Okay. Then we have architecture, because nothing works without the architecture. And then you have security and privacy. Also, you need this. And then you have trustworthiness, okay? So all those things, the data space must take into account. Sorry to say, but it's huge, okay? And then at the end of the day, you have artificial intelligence, okay? So this is what we need, okay? So this picture shows a little bit snapshot of the needed standards that we need to take into account, okay? So, but I want to show to you the same thing for privacy, okay? Privacy, we have, let's say, foundational standards, but then we have engineering standards, okay? And then we will have organizational standards, particularly for conformance. Then you have de-identification standards. We want to make sure that you are hiding some information which relates to personal data. And then you have, again, data and AI here, which I want to use. And at the end, the solutions, IoT and digital twins, okay? So this is, again, another way to look at all those, let's say, incredible list of standards, but in reality, they are related to each other, okay? So I have also, I think that's my last slide. I just want to conclude that the standardization, so ISO, IEC, ITU, they're currently working on what they call SMART, okay? So SMART standards, which are actually allowing us to create dynamically the real specification of the standard you need. So you will take a subset of this, and this, and you have one vision, okay? So it's a huge undertaking. I think it's going to be slower than the advent of a data space, but it's going to be in the pipe, and hopefully in the future it will help us, okay? And yeah, I forgot application, sorry, I forgot this one. So at the end of the day, you have privacy for smart cities, for fintech, age assurance. This one is new, privacy of metaverse, okay? It's newly started, okay? And to conclude, I want to say that we have created a interest group in Eclipse called Models for Privacy. And definitely the reason for doing this is to understand the use cases and the guidance on how we are going to use properly AI and data space. So that's it. Thank you so much.
Thank you, Antonio. Impressive, the number of standardization activities that you are involved and promoting. Thank you for the presentation and the great job. And then we will have time at the end for questions, okay, and to discuss. And now, if Javier Valino, can you join Javier Valino, because I would like to close the part of standardization bodies presentation with your presentation, if you are ready. Okay, that's perfect. And then we move to the part of the project results and explanation. Okay. Thank you, Javier. Great. The floor is yours.
Thanks to you, Silvia, and Omega-X for inviting me. You know, Omega-X has a special place in my heart. So very happy to be here. Good. So hopefully you can see my screen now, right?
Yes, perfect.
So I would like to introduce you to what we are doing in the Eclipse Dataspaces Working Group, which is where we are trying to as well conduct some standardization activities. So I will start first with the introduction to the working group, so you can see who we are, what we are doing. So you can see on the right-hand side of the slide our strategic members. So these are not the full set of members we have in the working group, but those are the ones that are working intensively and weekly together with us, so we can drive the work that we are trying to do here. And on the left-hand side, you can see an extract of our charter, which is summarizing our mission statement and our objectives. I won't go through all what is said here. You can have a read on this later, as you will have these slides, and you can also look at it on our webpage. I would like to stress 3 pillars that are coming out of this mission statement and objectives. The first one is interoperability. So we have been talking about this throughout all the presentations. So everybody who is working in the data spaces working group is acknowledging that the biggest challenge for data spaces so far is interoperability, and we are trying to solve it using two powerful tools. The first one is open source, as you might imagine, given that the Eclipse Foundation is an open source foundation. So open source is the way we see we can solve it. And the second pillar would be standardization. So this is what this webinar is about, and this is what I will concentrate on, the message I am trying to convey. So looking at this slide, which is trying to sum up everything that we are doing together, so don't be scared about all the things that are listed here. I will try to summarize, starting left to right. The left-hand side is what we already saw in Sebastian's presentation, which is basically the standardization request that is coming from the European Commission. So starting from the Data Act, the Commission is clearly saying that they want this to be standardized, and they see data spaces as the way forward to what they call the digital single market. So very important messages from the European Commission. Data spaces are important, and data spaces need to be standardized and adopted. So looking at this request from the European Commission and also from the wider data space environment, the working group is trying to address it through two different actionable results. You can see them. The first one is the one you can see on the gray background, which is open source specification and standardization. This is the message I will try to concentrate on this presentation. So we are trying to provide open source specification for protocols and profiles that are fostering this interoperability for data spaces. The outcome of this work will be conveyed to the standardization bodies. We already discussed those here in this webinar, ISO, IEC, and CENELEC. So our goal is to provide them with these technical standards. And the second actionable item that you can see highlighted in purple background is adoption. So whenever we have these standards, we will try to push them so they are adopted on the open source modules and software that we can see for data spaces, so that everybody who is using those open source data space modules can be by default compliant with the standards that we were trying to push to this standardization organization. So as a result of this second actionable item, we will have a set of modules, a set of projects that anybody could use in order to build open source and interoperable data spaces. So that's the overall goal for the working group. Two actionable items, technical standards and ready-to-use open source modules for data spaces. From now on, I will concentrate on the upper part, the part on standardization. So zooming in on the stack of protocols that we are trying to standardize as part of the data spaces working group. First, you can see on the right-hand side, the stack of protocols or the master categories that we see on this stack of protocols for interoperability. Starting bottom up, the first thing we think we need is what we call a base protocol. So it's an abstract message protocol for interacting with the catalog, with the contracts, and for orchestrating the control plane of the data transfer. It is very linked to the next stack in the pile, which is the bindings. So how to wire it to the protocols such as HTTP so that it works. And as you can see, these two layers are matching what we are trying to do with the Eclipse Dataspace protocol. This would be the basic cornerstone for technical interoperability. This is something that is already implemented to the version that is available now in IDSA, for instance, and it is being implemented as well in many other data space modules. So we are very happy to see that the ecosystem is, there is a consensus on the ecosystem that this should be used and standardized. And good news as well from the Dataspace Protocol project. They are already in what we call a progress review at Eclipse, meaning that they are very, very close to the release. And we are hoping this protocol to be ready for release in late summer, August, September, and starting the transposition as an international standard at ISO IEC level, starting in the last half of this year, hopefully making it into an international standard before the end of the year. If we move up on the pile, on top of the base protocol and the bindings, we see claims protocol, which are as well message protocols that are ruling the way we are exchanging and using our claims. And by claims, we understand identity claims, for instance, but also the way we are describing our data offerings or service offerings, as you do in Omega-X. For this, we are trying to standardize as well the Eclipse Dataspace Decentralized Claims Protocol, which is as well in a very mature stage. And we hope for this as well to be standardized in late 2025. And finally, on top of those base protocols, bindings, and claims protocols, we are trying to provide specifications for what we call policy and credential profiles. So those are the ODRL policy models that are mapping what we call in our ecosystem the trust frameworks. So for instance, the Gaia-X trust framework will have its own profile, which is the one you can see listed as Eclipse Conformity Assessment and Policy and Credential Profile. And some other trust frameworks, such as IDSA trust framework, is as well trying to do the same with the Eclipse Data Rights Policy Profile. And we might have many other profiles that are matching different trust frameworks across the world, because for the trust framework, we understand that this is very region dependent or data space dependent. So one data space might be willing to adopt one or the other. So there might be multiple profiles in the ecosystem. But why are we doing this in the Eclipse Dataspaces Working Group instead of maybe going directly to ISO, IEC and start the standardization there? Because there is one fundamental thing we have at the Eclipse Foundation, which is a differentiator, and it is what ISO IEC calls PAS submitter. PAS as in public available specification submitter. So this status is just granted to 17 companies or organizations around the world, and it is kind of acknowledging that we at the Eclipse Foundation do the specification and standardization process seriously, and therefore we can shortcut the way for preparing international standards. What you can see on this slide is the usual roadmap for any protocol or a thing that wants to be standardized. And as you can see, it is lasting from 2 to 3 years. But if we do this work at the Eclipse Foundation, we can start preparing this specification at the Eclipse Foundation, as we are doing for these 4 protocols and profiles you saw in the previous slide. And we can enter directly at the DIS, Draft International Standard stage. We can have a 3-month ballot for approving the current specification. And if no comments or no major technical comments, we can directly transpose it into an international standard. So we can do it in 6 to 9 months instead of waiting for 3 years. So that's the value we are adding to the standardization pipeline of data space protocols. And this is what we are trying to do with these 4 protocols. Very briefly, why should you maybe consider working together with us in this standardization and open source adoption process for data spaces? This is the complete set of advantages anybody would have by joining the working group, but I will focus on the top level, which is the ones that are linked to the standardization activities. So if you join us and start working together on standardization, you will have a direct say on the way we are structuring the pile of protocols and the way we are working directly with those standardization protocols. As you can see, there are many others as well for implementation. So you can also provide a strategy layer for the open source data space projects. And there is also a good value on positioning and making sure that everybody knows that you are a data space expert and you are in the right place, producing the right results, at least in terms of open source. So this is very important for some people, as we call them, the strategic member profile of members. Those are members that are really interested in standardization, or they are dependent on some open source technologies for their products. So if you are matching this profile, I will be happy to discuss with you how to collaborate, but as well as a project as Omega-X, maybe not now for Omega-X because you are ending, but for any other project that you are working on. We are open as well to collaborate with this project. In a sense, this would be a way to revert back to the community what you are reusing. So for instance, we know Omega-X is using IDSA and some other open source technologies. By applying to join the working group as a sponsor or a supporter member, you can revert back to the community what you are reusing, and you can make sure that everything is going right. With this, just we'll leave you with this last slide with some resources you can click on and see additional information. And that's everything I wanted to say. Thank you very much, Silvia and Omega-X, and happy to discuss on the question and answer section.
Thank you, Javier. It's great to have you here. I was with you on the kickoff meeting of Omega-X, and now you are here standardizing data spaces and part of what we have developed. So with your presentation, we close this first part of the workshop with presentations from standardization committees. And now, next 3 presentations, we want to introduce you on the results, some of the results of Omega-X at high level, but also the results of the interoperability framework. And Eric Makeda, that is the technical coordinator of Omega-X, will explain us how was this interoperability testing. And then we will have time for questions, okay, and discussions. So let me explain you next 10 minutes about the activities, the standardization activities that we have developed in Omega-X, and how we have tried to contribute to standards, because I have to recognize that this is very challenging to know how to contribute. We are all learning. I am learning. I expect that most of you with these presentations has learned also how to contribute to the standards and be able to do that. But the first challenge was to capture the knowledge, what is being done on the project from different groups, from the different use cases, in order to explore which standards has been implemented, and then based on these implementations, which has been the challenges, the needs, gaps, and how to contribute to the standard. So in order to capture this information, we organized 2 face-to-face physical workshops where consortium members could contribute and provide feedback on these topics. For that, we use the method of World Café, and the topics around the discussions about which has been the challenge, the gaps, which standards have been implemented, which standards are missing. We organize around one topic, data interoperability and privacy preserving technologies. Another topic was more related to the energy domain, smart grids and use cases. And the third topic, also on energy domain, were more focused on communication and interoperability, metering and data exchange and general aspects. So keeping in mind these 3 approaches, we asked the questions, okay, which are the gaps, recommendations, and we identified more than 57 standards. We collected around 19 recommendations, and we work on a report of these recommendations. These recommendations are at high level, so don't expect specifications, okay? These are more challenges, gaps that they encountered during the implementation of the project. Regarding data interoperability, one of the recommendations was establish an structured methodology for acquiring knowledge from products before diving into the technical aspects. Another recommendation was regarding the challenges of the heterogeneous data sets. And then we will have a presentation about how we have solved the problem of the semantic interoperability. But this heterogeneity is also within the same database. And here we propose implementing standardized data structures and ontologies. Also related to this data heterogeneity is a proposal to standardize database solutions, to have a common database software standard to ensure consistency. And then also regarding data exchange format, there is a proposal to define and promote standardized formats for data exchange. For example, JSON, CSV, in order to enhance interoperability. And then we recommend to work closely with IDSA experts on Vocabulary Hub in order to improve the semantic interoperability across systems based on the experience of developing the CSDM framework that Fatma is going to explain later for managing the Vocabulary Hub in Omega-X. And then another recommendation is develop a standardized semantic data modeling methodology, and that aligns with the existing standards and well-known ontologies. So this standardized data modeling methodology will facilitate how to achieve interoperability, how to define this semantic interoperability. Another recommendation is related to artificial intelligence driving maintenance forecast. It means to leverage AI-based predictive maintenance techniques to optimize the assets management and enhance and facilitate the operational efficiency. And then we further discussed a specific topic that is the data space interoperability. And the experience of implementing the connectors and the interoperability between the projects, we identified the following challenges and recommendations. When we face the connector-to-connector communication interface, we struggled to achieve the interoperability due to the different connectors implemented different data space protocol versions. So there are data space protocol versions that are not interoperable. So we recommend using compatible versions, and also the group that is developing the data space protocol standardization clearly publish and communicate which versions are compatible in order to facilitate this interoperability. And then going to the identity management, each data space define their own trust anchor and may force customized verifiable credentials schemas. With these verifiable credential schemas has specific required attributes, formal and credential types. This leads to incompatibilities between verifiable credential and between verifiable protocols when we are crossing data spaces, and then fails the authentication and the authorization flow. For example, because the one attribute is required in one data space, but doesn't exist in another data space. So this difference on the attributes has been to solve. Another challenge was the barrier to peer-to-peer interoperability, especially in each data space evolve independent without common standards. So it was difficult to achieve this interoperability, this technical interoperability. And the group recommended adopting a sharing cross-data space credential profile. So I was happy to see on the Eclipse, on Javier's presentation, that you are standardizing this credential profile. And for this moment, we have the projects has to decide how to interconnect the data space, for example, using the same protocol OID for verifiable credentials. And then regarding the connector management API, one challenge was the lack of a standardized connector metadata access. So in environments like Omega-X, where multiple connector implementations and versions coexist, managing them via a unified interface is difficult. Why? Because each connector may expose a different set of management endpoints of a schema. The IDSA management API doesn't expose metadata lags connector types, which are the connectors versions, and also, very important, relevant, the supported features. So, for example, contracts negotiation, policy management, and this makes it hard to debug compatibility issues, ensure lifecycle consistency, provide support to the users. So the recommendation is define a connector metadata endpoints specification to improve management, standardization, and also the user experience. For example, use IDSA information model as a base and extend it to cover all the necessities that has been identified. This is regarding data spaces interoperability, but in Omega-X, we identified also more specific recommendations, gaps regarding energy domain, and explicitly about smart grids and the use cases, the different implementation use cases. We identified the following recommendations: data model standards for smart meters, establishing uniform data models for interoperability and seamless integration, standardizing smart meter parameters, defining a common set of measurable parameters, for example, voltage, frequency, consumption for global harmonization, service provisioning, enable automated service provisioning, such as dynamic traffic and real-time billing, using blockchains-based smart contracts, for example, or service virtualization, implement digital twins, cloud-based energy management, and AI-driven predictive maintenance for grid optimization, and also service quality evaluation, define KPIs, real-time monitoring, and power quality standards for reliability assessment. Also, endpoints lifecycle, standardize onboarding, updates, and decommissioning of grid devices while ensuring cybersecurity compliance. And sharing best practice following these standards to document and update best practice for emerging technologies in smart grids. And continuing on the energy domain, but going more on the topic on the field of communication, interoperability, metering, data exchange, and other general aspects, we identified the needs, the following needs and gaps. One is standardized forecasting for energy system. We need for a standardized approach to forecast in energy system. Also regarding blockchain and generative AI, ensuring trust in AI-generated outputs and blockchain applications. And then we have a couple of needs regarding open charge point interface, but also open charge point protocols. And one is a lack of standardized interoperability mechanisms for electrical vehicles. optimal plan reservations, and also no clear framework for planned reservation reproducibility. So here I was happy to see on the presentation before that there are committees on standardizing on it. And then need for reinforce or formalize the open charging point protocol further, okay? And then another point is the lack of common semantic biddings, no common methodology today to handle user agents variability. And then common standards for data exchange. Need common standards, it has appeared before, for seamless data interoperability on this energy domain. Recommendations, standardized forecasting methods, develop reservation mechanisms in open charging points interface, improve the interoperability and reproducibility, ensure semantic interoperability, collaborating with the standardization bodies for creating a unified methodology, and strengthen the open charging points protocol as an industrial standard. And to finalize my presentation, because Eric will introduce about the achievements on the results on the semantic interoperability use case test integration live demo in Bilbao last March 5 of March. But here you have a very high level, a summary of the findings, difficulties. So it's challenging to achieve interoperability across different components. We need a standardized onboarding and verifiable credentials, challenging to align different projects and architectures, metadata synchronization issues in data space, difference in contract negotiation across platforms, lack of unified semantic data binding methodology, and also adopt standardized credentials as OpenDI or ADAS for authentication, ensure compatibility between data space connectors, encourage common data formats for interoperability, and develop a standardized methodology for metadata exchange, promote cross-domain collaboration and alignment with European digital identity frameworks, and continue testing interoperability scenarios with real use cases. And with this, I finalize my presentation and give the floor to Fatma to explain. Yeah, can you share your screen, Fatma?
Yes, of course. This is Carmen. Please.
Okay.
Let me know if you can see my screen.
Yes. Perfect. If you put in presentation mode, it will be.
Yeah, this is Carmen.
Okay, thank you.
Is it okay?
Okay, perfect.
Perfect. So hello, everyone. Thank you, Sylvia, and thank you, Arturo, for providing this, the context for this workshop today. I'm going to present the common semantic data model and how the semantic interoperability topic has been addressed in the Omega-X project. So, yes, a brief context, because semantic interoperability is something that has been stressed in previous presentations, but it's a very important topic that would never be emphasized enough. So the semantic interoperability in the data space is a key challenge, because the main mission of a data space is to ensure that datasets and services, data services, are exchanged and accessed, shared in a seamless way. And heterogeneity is a key challenge in this case. Why? Because we are dealing with multiple entities, organizations sharing data and services in multiple formats, languages, but also with different and various underlying schemas, which complicates the main mission of a data space, which is to enable discovering and tracing datasets for use cases, and also understanding the data behind for optimal use in expected use cases. For example, as if we locate a data space user, come into the data space to discover some interest in energy domain datasets, for example, in the renewable domain, to feed some AI system and to train some AI system for energy forecasting, for example. The user is coming with some query to the data space with some keywords about the electrical photovoltaic production, about some region in Europe or wherever, and about some temporal context. And here, this query to the data space is going to face a data catalog with really different data sets with, as I said, fragmented schemas, heterogeneous formats, and so on. So we are having some set of returned data sets, but also a set of questions related to the results. Does it exhaustively cover my search needs? Do I have for this dataset required metadata to describe quality? And the metadata topic has been also introduced by Sebastian earlier. So to trust the dataset I'm getting, to understand the content, and also to use it by having this quality criteria attached to it. So that's why common knowledge representation as a building block of a data space is very crucial to ensure the semantic interoperability in order first to get wider discoverability rate to these datasets and data services, but also to the step beyond to ensure the data understanding once got from the data space, to ensure to get enough knowledge to derive necessary insights and to get some quality metrics for data validation. So the main task for the group working on semantic interoperability in Omega-X Dataspace is really to develop this common knowledge representation called Common Semantic Data Model. But to do so, we had all to develop some methodology to create this common semantic data model to ensure that we are aligned with European recommendations and best practices related to common knowledge representation frameworks, developments, and semantic interoperability guidelines. That's why we first worked on a methodology to create this common semantic data model. And one important point about this methodology, which is AME, Agile Interaction Model-Based Methodology for Energy Data Spaces, is that it ensures a gap in existing methodologies. We knew from the beginning that a very challenging player in the game is to rely on standards, on domain standards, not only on existing ontologies that are, of course, very useful, but to try to reconcile and create a framework where standards that are not necessarily always provided in semantic RDF formats or ontological formats to reconcile them with the existing ontologies. And that's why we try to create this methodology to ensure a harmonized way to incorporate knowledge from both ontologies and standards. And also, very important, to ensure adherence to fair data principles from the Energy Data Act that ensures that we can find, access, and reuse assets we are defining through the methodology. So as an output of the application of the methodology, we've defined the common semantic data model, which is not one big ontology encoded in one big file, but as best practices recommend to include 12 modules on 3 interoperability levels. And we will see later why different interoperability levels are important in our case. So to briefly describe the framework and the common semantic data model, we have 12 modules. The core module in blue will relate to shared datasets structures. So we are going to describe how data are represented in terms of events, measurements, time series, data collections. And this is something common to all data spaces, even if we are not talking about energy, even if beyond Omega-X projects, we can share the way we are representing data sets. And then in the second level, let's say we are more in the domain level, energy domain, where we will focus on the infrastructure of the energy domain, the properties, so the physical characteristics we are observing, quality metrics, and so on. The third level is really the use case families level, because we have 4 use case families in the Omega-X project that are renewables, electromobility, flexibility, and local energy communities. And in each use case family, we have specific representation of knowledge, for example, of the infrastructure specific to these use cases that is defined in specific modules. This is done in an agile way to avoid that overwhelming common modules, for example, the infrastructure that will be common if we are talking with other systems or data spaces with systems connected, with specification that could be really specific to one use case in renewables, for example. So the 12 modules constitute the CSDM. The CSDM has been published as an open source software solution with a repository with all codes, the ontology modules, but also a toolset that enables to understand how to transform data from raw formats, for example, CSV, JSON, wherever, into this knowledge graph, which is compliant with the common knowledge representation format. We have also a website with some documentation, which is very useful when we do not need to dive into the technical details about the module, but need to understand and overview the scope of each module. I think that I will just go through the main lines about the modules constituting the CSDM. We won't have time to really present them in detail, but the idea is to see what is the scope of each one. The first one, as I said, is focused on the dataset structure, covering how we can represent data points, events, the values that are very important in terms of processing and services, but also some complex data structures as data collections, collections of collections, or time series, and so on. And a very important point about the events and time series, so the core ontological module, is the links to quality metadata, so the quality metrics, the aggregation, the measuring procedure, all data that should provide some quality description about the dataset, the properties that are described, and some context about locations or temporal entities. Then we worked on the properties to explain how we represent types of physical characteristics such as active energy or temperature and wherever, but also to create a control, some vocabulary about what are the list of properties that we've been using in the Omega-X project, because the representation was very different from one case to another, and it was very important to rely on one standard source, which is here the Electropedia, the world's online electrotechnical vocabulary for defining energy domain and electrical field properties, to get this controlled vocabulary of how we define the properties. So this is an overview, a partial overview of the taxonomy. We have also one module to explain the exchange context, the technical context of a data space, of a data set. Of course, we are in a data space, so we have some participants that constitute the source and the target of a data set, for example, but also some device maybe behind the data set that is useful to understand the provenance of the data. Very important also, we had one specific module that encodes and reuses the human metering profile from IDSA 61968, which will be used in semantic interoperability tests with other energy domain data space that will be later presented by Eric. So it really represents all the metering data and how we can encode them in standardized way, but as an ontological module. And then a very important topic in an energy domain data space, talking about the infrastructure. As I said earlier, we can see this high-level interoperability level about infrastructure, which is how systems are interconnected and what are the system kinds, so a taxonomy of system kinds that could be provided in the energy domain, and also attaching some system configuration that could be from the manufacturer, for example, some owners, for example, of each system, so really high-level interoperability that enables to just describe the systems. But this specific module, which reuses and some concepts from the IDSA for system, is specified then in the 4 use case family modules that are the renewables, which is fully compliant with the IEC 61850 for the renewable solar infrastructures from electrical power systems, PV panels, and so on. We have also one module for the flexibility, operations, and the grid representation, which is compliant with the IEC 62746, same profile. We have one module from the local energy communities, which represent really the equipment from transformer, batteries, and their characteristics. And finally, another use case family module, which is electromobility, that explains what is the infrastructure of a charging station and equipment related required to understand the electromobility infrastructure. So that said, we have also some modules for metadata, such as quality, which is compliant with ISO 25012. We have a module for scheduling operations, very relevant for flexibility use case family operations. And we have a module for energy roles, very important in the energy domain to explicit the exchange context of the dataset to see who are the participants. And here we've relied on the IEC 62325 standard to explicit the market role and the market participants. So to sum up, the Common Semantic Data Model is an open source framework, is a solution that has been developed to ensure semantic interoperability within the project. It has been applied in the 10 pilot sites in the project, used to semantify over 12 datasets that were exchanged between data providers and service providers. The solution is published through W3ID permanent URIs, which is a best practice and highly recommended for semantic assets, provided with a required documentation and guidance, and has been used, but I will let Eric explain more at this point, in the IDSCP interoperability tests, in the metering use case held in Bilbao, as Sylvia said, between 5 sister projects in the energy domain, so ED, Energia, Synergies, Datasela, and Omega-X, which showcase how it has been leveraged to ensure interoperability within the project, but also beyond with other system projects. And we are working to push this work done in the Omega-X project into standardization through some presentations to relevant committees, such as a joint working group of ENSOE and Europe DSO entity, Data for Energy subgroup of the European Commission, CENELEC, IDSA, IEC committees and working groups, and as Sebastian presented, the IDSA Technical Committee on Data, and other entities, relevant entities that are not necessarily listed. So, thank you. And I head back to you, Sylvia.
Thank you, Fatma. And now, Eric, thank you for the, great job, great work, and really interesting. I don't know if, Eric, are you ready for sharing your screen? Perfect. We can see your screen.
Yeah. Hello, everyone, and good to see so many familiar faces at the end of this project. Okay, so, well, I will end up a bit trying to put a bit the results on all this interoperability work that we've been doing, specifically for these energy data spaces. So, as you know, well, this has been a work not only from Omega-X, but along with other sister projects such as NRSER, DataCellar, EDI, and Synergies, along with the coordination of INNET. And we have also had some interactions with what we call the outer layer, so other projects that are related as well, working on this data spaces ecosystem, such as Odeon, TwinEU, HIoT, Begonia, and Interstore. So today I will present a bit the work that we've been doing in the inner layer and to demonstrate the interoperability between the different data spaces that we have developed in the different projects. So for this, first we have produced some documentation, specifically the blueprint of the Common European Energy Data Space, what we call this CEDS, that contains a bit on the proposed architecture and some business and system use cases that have been identified as the ones where we believe that data spaces could have the biggest impact in the energy sector. This document will be used by the new project called Insieme that Arturo mentioned, and that will basically productionize these energy data spaces, and that is starting now in April. In addition, we have produced a paper around the interoperability framework in energy data spaces, which has been led by Sonia Jimenez in IDSA together with INNET. Okay, in this paper of the interoperability framework in energy data spaces, we covered all the state-of-the-art technologies and standards, and we focused on the interoperability specifically for the energy sector, covering from technical, semantic, organizational, and legal interoperability. And we also covered the cross-domain interoperability, specifically with mobility use case, which is tightly related to the energy thanks to these EVs. Also, we describe the benefits of achieving this interoperability for the different actors in the energy sector, and we put the plan towards this interoperability between the different sister projects with some defining some system use case that I will present later. Okay. Also, well, we define with all these sister projects a proposed architecture for these energy data spaces, which is the typical architecture that we are all used to. Basically, we can see two different layers. On the one hand, what we call the data platform layers, which are the usual data platforms that different organizations have connected to their IoT and legacy systems. And the key component here is always the connector, which federates these different platforms. And then we have the upper layer, the federated services, which cover the part on trust, covering identity management and access and usage control, and the part on the catalog for the publication and discovery of data products. Okay, so we did a mapping at the beginning of all these different components, how they were implemented in the different sister projects. As you can see here, there was a big variety of solutions, some based on IDSA, some based on Gaia-X, some based in other technological stack, and so on. So then try to be pragmatic to try to demonstrate the interoperability of these different components from the proposed architecture. We define 5 system use cases. The first 4 were focused on technical interoperability, specifically the part on onboarding, which was mainly on the part on interoperability of the trust part. Then system use case 2, which was around interoperability of the catalog and to be able to discover and push data products into different catalogs from different data spaces. System use case 3 around contracting. And the fourth one, which was an overarching system use case relying on the previous 3, that was the final step to be able to exchange data between different data spaces. And finally, we define a 5th system use case for semantic interoperability. All these system use cases were successfully validated in a live demo that was held in Bilbao a few weeks ago in our offices in Tecnalia. And today I will give you a brief summary of the results of this demonstration on the different system use cases and the key takeaways and recommendations. Okay, so regarding the first system use case around onboarding, in this case, NRShare and Omega-X project, we successfully validated the interoperability of verifiable credentials. So as you can see here, from Omega-X side, we developed a verifiable credential issuer based on OpenID for verifiable credential issuing protocol. And specifically, we used the authorized flow. And for the authorization endpoint, we relied on IDSA tabs. So with this, we were able to generate credentials for different participants in Omega-X and in other projects. And in this case, we generated a credential for an NRShare participant that was requested through the connector, the TSG connector from TNO that is used in NRShare. And then they used this credential to present it to another NRShare participant using the Eclipse Decentralized Claims Protocol. And this worked perfectly, the same as it was working in their data space with the credentials generated by the NRShare issuer. Okay. Second use case, in this case from Omega-X, we worked with data seller. So we perform on the part on onboarding into the Omega-X. So basically, a data seller participant performed the previous onboarding process into the Omega-X data space. They plugged their connector, synchronized their offerings, and they were able to publish a data product, as you can see in the top right, of data seller into the Omega-X marketplace. And they were also able to edit, delete offerings, and so on. The third one, which is related to the previous one, also with data seller, once this data product was published into the marketplace, we also went a step forward and do the part on contracting. So in this case, both projects are using the Eclipse Dataspace connector with subtle differences. So data seller is using the community-based version based on the one that is in GitHub and version 0.6. And in Omega-X, we are using the Sobity extension of the EDC, which is based on EDC version 0.7, which is version 11 from Sobity. So for this, we also use these verifiable credentials that we discussed previously. And for the contracting part, we based on the IDS Dataspace protocol. We tried different methods, the pull and push method, and in the end, we agreed to use the pull method. And actually, after all this, Sobity confirmed that they are going to deprecate the push method after for the next version. Furthermore, once this data offer was contracted, we even transfer this data through these connectors from data seller to Omega-X, and it worked. Okay. Then going into the system use case 4, as I said, this is an overarching system use case that relies on the previous 3. And here we did a test with actual connectors, as I explained before, with data seller and Omega-X, using this dataspace protocol and the EDC connectors. And also from Synergies and EDI project, did another test using some more standard existing technologies currently used in the energy sector, using REST API endpoints and public subscription mechanisms such as Kafka and MQTT. Okay, and finally, we also demonstrated system use case 5 on semantic interoperability among all the 5 sister projects. In this case, we focused on smart metering data, and we used the UMET, what is called European Union My Energy Data Metering Profile, which is based on the IEC 61968 edition 3 standard as a common data model. So each project defined specific mappings or alignments to this common UMET metering profile, and we demonstrated the interoperability using different formats such as JSON, XML, JSON-LD, or TTL. Okay, so now the key takeaways from this interoperability test is that regarding the interoperability of verifiable credentials and presentations, it went quite smoothly using existing standards such as this OpenID for verifiable credentials and the Eclipse decentralized claims protocol. We understand that obviously some work is still required, but it went quite smoothly. However, in the case of the connector, it was not really the case. I know that, well, the Dataspace protocol was published not so long ago, and that there are other projects that have actually demonstrated, but in our case, with the different sister projects, with the variety of solutions that you could see before in the initial table, it was quite challenging to do it. So even if the case of DataSeller and Omega-X both using Eclipse Dataspace connectors, those minor differences between different versions, well, it was quite challenging to solve it. Also, some projects stated that, well, relying on a single data transfer method using connectors is not enough, and we have to also cover other legacy systems that are currently used in energy sectors, such as these public subscription mechanisms and so on. And also, it was highlighted the importance of the semantic interoperability and to be able to handle different formats, not only like a standardized JSON-LD or TTL, but other formats such as XML and so on that are currently used by legacy system in the energy sector. Okay, and finally, regarding the recommendations, so one recommendation was around enhancing this interoperability of connectors and including more effective version management systems. Also, to integrate Dataspace connectors with real-time data streams and public subscription mechanisms. Also, regarding semantic interoperability, it was highlighted the necessity to enhance this using other SIM profiles, not only this metering profile, but the other ones such as the market profile, and even bridging the gap between the IEC SIM with other reference on standard ontologies such as RF and so on. And finally, I think that one recommendation, and because we think this test was really useful to basically translate from paper, from the initial papers that we wrote to actual practice, and this helped us to find some issues that we were not aware of and solve them. And we think this was quite good initiatives, and we highly recommend to keep on doing this regular interoperability test, even with other cross-domain data spaces, to be able to progress on this matter. And that's all from my side. I don't know if there are any questions, comments.
Thank you, Eric. Very good presentation, and yeah, a good summary of all the activities that you have been developed beyond Omega-X in collaboration with other projects. We are at the last 2 minutes. Time for one question from the audience. Okay. I will try to, you can write or you can unmute. 1 second. Let me allow you to open your camera, your microphone. If you want to ask, please just unmute yourself, raise the hand. No questions? So I have one question, Antonio. You have commented that you are involved in several standardization activities running at this moment. And one question is how we can contribute from Omega-X or also the experts that are here, or maybe other projects. If they want to provide feedback, contribute, how we can do that, where we can find information about these standards. We have the slides, but if you maybe go into the BDBA Standardization Working Group, but it's just for members. So, yeah, thank you.
The approach is the following. If someone is member of AITI or BDBA and part of the working group on standardization, we can make available, because then you follow the rules of liaison, okay? So this is rather strict. So you can only use it, and there will be some kind of a preliminary, let's say, warning. So you'll only use it, let's say, for the purpose of studying standards and contributing to them, okay? So, and then what other things is that within European projects, we could publish, and actually Standard ICT is asking for that, okay, to publish, let's say, presentations and summary. And for instance, we had a very big documents on AI standards with like, data space and data standards. There were like 50 projects, okay, published or non-published. And this is really interesting. And one of the goals we have is for maybe June to provide a version that is IP copyright free. I mean, it's something that actually ISO can publish for free, okay? Okay. And so we will have both. My goal will have both. One which is actually copyright free, so only things that are available on the web, and one thing which goes much more in detail, but only for ISO people, because sometimes they need more, okay? So this is what we have in mind. We published this document in April last year. So, but it is a copyright, including copyright stuff. So it's completely internal to JTC1. Okay.
Okay.
So this could be an effort. And then we can also work together, because it's also the single view of SC41. And if, for instance, people in SC38, IDSA, Eclipse, and others, they help, then we have probably a slightly more balanced version of the document. Okay.
Okay. Thank you. So thank you very much to the attendees for remaining up to the end of the session. And the recording and the slides will be available on Omega-X website. And you can see, if you couldn't, you can review or you can share with your colleagues. Thank you, all the speakers also, for contributing to this great job. Bye.
Take care.
Thank you.
Bye-bye.
Bye.